Hello everyone, my name is Salim Musaad, and today our project will be talking about modification on an induction motor identified as a house ceiling fan, converting it into a permanent magnet alternator or else a permanent magnet generator that will be used as a wind turbine to charge batteries connected to our system. First of all, to talk about what we're gonna do in the next steps, we need to talk practical parts seen in this ceiling fan. As we can see, this is the main shaft and this is our rotor from the outside. We're gonna move on to the inside part. As we can see, first, these are the primary windings in the stator and these are the auxiliary windings in the stator. This is the shaft and this is the rotor. Basically, this metallic bar is the rotor and held into the seat. As we can see, the phase angle shift between the auxiliary winding and the primary winding is 90 degrees. The primary winding is held by the lamination. This machine have 18 poles that have north and south polarities respectively. Electric current will pass through these windings, making torque that will move the fan blades due to the phase shift. We move on to different steps on how we modified it. First, we moved on to this step. We added in the rotor the magnetic bars. As we can see in this, we added 14 magnetic bars with opposite polarities and that are equidistant in here. As we can see, when it's held, the wind will strike the blades located on the rotor, forcing a rotational magnetic field due to the permanent magnet in it. This magnetic field will induce a current in the primary windings. One major setback of the machine is the copper wire small diameter causing unsteady current and the auxiliary windings that are not used to take the output current from. Since we know that we don't need the phase difference and the auxiliary part, we removed it. We added our own wires with larger diameter and more turns. These wires will induce a current. Let's see what will happen. This is the shaft basically. The rotor would be held into the blades. As the wind strikes, this will rotate. This rotation causes the magnets inside this rotor to make a rotating magnetic field that will have an induced current in these wires that will be at the end taken from these two wires only. As we can see, the flickering light of the 220 volt lamp due to the uncontinuous current and the relatively high output voltage at low RPM. The second machine showed higher potential with a 24 volt output and a 3 ampere AC current when tested on a 75 watt lamp. Our RPM will be modified by using spinning levers. Furthermore, output wires will be followed by a rectifier bridge, a DC to DC converter and diodes in order to charge batteries attached to our system. To conclude, many factors play a huge role in our results, from mechanical frequencies to winding turn ratios, slots, and many others. Further testing and calculation is needed to increase our output current and voltage. Hope you enjoyed this video and thank you for your time.